I will be very brief. I'm here to bring you good news. I'm here to introduce you to cerium oxide nanoparticles. This is something that in the future may have a huge impact in human health and social health. This is 3 nanometer cerium oxide nanoparticles. They are extremely small, well, smaller than proteins, much smaller than cells and all that. It's like little grains of salt, like 3 nanometers. A sugar molecule is 1 nanometer. It's like 3 sugar molecules, and they are immunomodulators. They eat free radicals. They are very efficient anti-ROS agents, anti-XR-ROS only. They don't quench a natural metabolism. So that's very nice. And we are developing it and applying to different fields, and this should go ahead and bigger. And this goes to the antioxidant dreams and what I call the malediction of Linus Pauling. Linus Pauling is the only person in Earth who had 2 Nobel Prizes solo. And when he got old, he discovered ascorbic acid and free radicals and metabolism and all those things that was discovered like in the 60s, 50s, 60s. And he was convinced that if we take 1 gram of ascorbic acid per day, we won't have cancer, we won't age, and blah, blah, blah. He invented the Orthomolecular Medicine Institute, and he wanted orthomolecular medicine for everyone. Let's go for that. But nothing happen really. And this happened again in the 90s with huge studies in the clinic with vitamin D, vitamin E, and nothing happened. And that was very frustrating because mechanistically, antioxidants, they have a lot of meaning. They are it's got a good reason to use them, and epidemiologically also we see the good things of diet, of having an antioxidant life is very good. And even now linoleic acid is an antioxidant, and also the lactohydrin is antioxidant, and we don't call them antioxidants anymore because antioxidants has been already something for the magic crystals and other homeopathy and things like that, but still it's there. And then happens that cerium oxide nanoparticles arrive, and they are mineral, and they do the job that we couldn't do it before. We have tried to make antioxidant therapies with natural substance mainly, flavonoids, tannic acid, curcuma, green tea, and all these omega-3 and all those things, but they don't work very well because they are not drugs. The drug-likeness is very, very little, so they don't enter into the body. They antioxidize anything before entering in blood. The viability is very low. The reactivity is too high, and this doesn't happen with the cerium oxide. The cerium oxide is very soluble. It goes where it has to go, and only scavenge XR-ROS and immunomodulates very safely. So we're starting applying it to the liver because the blood, the liver cleans the blood. So we put some ceria in the blood and gets accumulated in the liver in a couple of hours, over 90% of the particles. So it's targeted medicine, and we have tested in all these diseases with good results. There's been tested in any disease because in any disease you will have in any disease, you have the regulated metabolism, inflammation, and consequently, this inflammation is burning. When you have a heat, it gets hot, and you get fever. Inflammation, it sets you on flames, and that's not good for your health. So try to do it. But even with cancer, I mean, we have seen new compounds for cancer, antioxidants. That's cerium oxide treated hepatocellular carcinoma, non-treated. This is angioimmunogenic T lymphoma that's non-treated, they die, and that's treated, they don't die. Because tumors, they have a weird metabolism. That was the Warburg effect discovered many decades ago. But in order to do any job, you have to use some energy, and we go to controlling the energy. You control what does the cell, apparently. For that, what we've been doing lately is to try to understand properly what is going on. So we go, that's the details of the experiments with the liver. But that's any little step is an animal. They are dying because of the disease, and when you treat them with that, they die later. You always die. We just try to postpone that event. And it's very safe, no side effects. It's orthobiological. It's just eating excess of ROS, doesn't get metabolized. It's a catalyst which gets eating excess of ROS until it degrades naturally in a matter of months, because cerium oxide nanoparticles, they love to be dissolved in the pH and acidity and the hypoxia conditions of the body. And then we went to try to understand how it works in the mitochondria, respiration, cell respiration. We burn sugar to be alive, and cells burn sugar and fatty acids to be alive also. And controlling how you provide energy, you control how to work the cell, and that is rather exciting. That's with immunology, I don't know, immunometabolism, the different roles of the immune system need different energy supply. So cutting the energy supply, you modulate the response of the immune system, which is something that you want to do in any type of disease. During autism, depression, there is also neuroinflammation. Disease and inflammation, they work together, so antioxidant substance may be good. And my final slide, as Eva was saying, the implementation of new technologies in society doesn't depend on how good these technologies are. It's a combination of scientific, technological, and societal forces. We have plenty of enormous opportunities that we didn't use because we were focusing something different. So I saw that even despite the good results in the preclinical models, the regulator was not going to allow us to inject cerium oxide nanoparticle, which is very weird. We moved to topical administration, like in the old times, unguents and poisons and beverages. That injections arrive very, very late in the medical practice. And so we developed this collyrium to treat the eye from degeneration, macular degeneration, rather orphan of treatment. You get injections of very expensive and stable antibodies, which have not very much effect, only in 10% of patients maybe. And we developed these little particles. You can put a drop in the eye and 3% of what you put goes to the back of the eye, to the retina, and then you cry the rest. And just the result. That's H. colon is an animal. That's the transcriptomics. So what they are is doing the cell, synthesizing things and proteins and doing things. This thing that it does is healthy animals, the eye of healthy animals. This is the eye of the diseased animals. They are getting blind. And this is the diseased animals treated with cerium oxide nanoparticles. You recover the healthy phenotype. This eye is suffering. This eye is not suffering. This eye is suffering. This not suffering, and this is suffering less than before. We are not curing here. We're just preventing degeneration. And this has been also tested in Parkinson, Alzheimer, sclerosis, and any animal model. You will find it in the literature. Developing the new concept of the drug, which is a little stone that doesn't work like a drug, doesn't get metabolized, and they aggregate in a different way. The proteins does it, and all that is a difficult task. So we get that published, patented, and now licensed, and we hope that we can start clinical trials any soon as the regulator approve it. Thank you for your attention.